Welcome to MyProjectBazaar.com. Our product title is LabVIEW based design of heart disease detection system. Now we are going to discuss about our product abstract. The variation in ECG parameters can be extremely fatal if not detected at any early stage. LabVIEW based virtual systems present in the works helps to detections of heart rate, ECG abnormality, and consequent estimating of the later disease using variation model. The model's record of ECG signals processing, display of heart rate, and possibility of relating disease have been designed using LabVIEW virtual instrument. The design system is advantageous in automatic removal of noise and accurate signal of virtual cardiograph and detections of P wave, QRS complete T wave and their onset and offset with the level and ST level elevation. This design have been tested on ECG database obtained from PCOnet. ECG is measurement of electrical activity of heart muscles obtained from the surface of skin. It measures the rate on regularly heartbeat and can be useful tool for LabVIEW. ECG signals show the electrical activities of myocardium. It appears the periodical signal. Generally, ECG cycles is labeled utilizing the letters P, Q, or S, T. Sometimes U wave or for the individual peaks of whole cycle waveform, where R is peak is always positive as on the flow. The ECG is a special digital band filters is used to reduce the false detections for ECG signals. Research have been proposed the wavelet transformations method for the detections of complete. The QRS complex can be identified for the high P or T level waveforms. In this work, simple and fast methods are employed to detect ECG parameters like QRS complex detections. Now we are going to discuss about our product flow diagram. So the LabVIEW has been used to accrue the ECG data obtained from PCOnet and display the raw ECG. After the data acquisition, the ECG waveform data are sent to the express virtual instrument for signal processing. This part of the process consists of digital filtering, the digital smoothing, wavelet deterrent, and wavelet denoise. The wavelet deterrent and wavelet denoise is part of the advanced signal processing toolbox, which is very useful for ECG signals processing. The signal processing removes the noise and power interference white noise from the signal. The signals passed the ECG features extractor, which give parameters of ECG waveform to calculate a heart rate and program with first and maximum and minimum value from the program. The processing signals are added to the decide the threshold needed for processing the peak and valley detections. The virtual instrument here provides the periods from peak and value. Thus, the heart rate based on the peak and value is obtained. After a heart rate calculation is done, the signal is passed through to disease detections models, which compare the ECG parameters with the normal parameters according to the some rule specified and indicate the disease in front panel of virtual instrument. The processor signals is simultaneously being displayed in front of panel is to result of each steps perform the virtual instrument designed. After that, the program loops for first stage and the state collect for next and data repeats the above process up to length predictions period. The flowchart has shown the figure explains the applied framework, which is divided the three major parts of ECG occurs pre-processing through the various filters, ECG feature extractions to estimate the disease lab detections of disease on basics heart rate and obtain the parameters deviations is done. The PQRS or QRS offset, QRS onset, ST level, ISO level. The heart rate model scan presented lab can be used the detections heart rate. This rate of the approximately equal to heart rate calculated from the biosignal rate using the mean cycle time between two R wave. Heart rate is equally is getting the various parameters of Ecg signals. Now we are going to discuss about our running procedure. So this is LabVIEW tool, LabVIEW 2013. So this is a block diagram tool, and then it has two functions of VI panel and block diagram panel. Oh, this is the VI panel. So this is output frame for anything. So graphical, so input path. So we are getting get the data set values Excel anyway some we are getting from here only. So we are getting the input data. So and data. So now we are going to running the so this is the input of signals, input was Ecg signals, and then low pass filter and high pass filters, and then this is the waveform for this. The filtered noise. So this is the filtered noise for Ecg signals, and then we are using the denoised signals. This is a denoise signals, and then detend the signals. Oh, these also the functions are these pots. So we are using the input signals, the path signals, and radius signals, and then this is the rate signals, these signals, and then low pass filters and high pass filters, wavelet denoised, and multi-trend. Oh, this is the input. How to we are pre-processing the Ecg signals, and then we are going to waveform features, Ecg features. We are getting the calculation parts for the Ecg features. The we are PQRS value on PCP onset, QRS onset, T onset. Yes, we are getting the normal abnormal. Normal abnormal we are getting using the mean values. So HR mean values. So this is HR mean values. Directions peak. This is HR mean values. So we are using the panel and so this is a normal abnormal, and the norm but we have heart rate value. This is 84. 84 means the person value heart rate is normal, and then this is for him. And then another we are checking that normal a 110 130 is abnormal. This is a bradycardia, tachycardia. This is VGT, this is occurred then.